Hello. Check. Check. Is it audible there? Audible? Sorry. Tarang team, hope I'm audible. Hope you're set for the dance. Great.
Singers, where are the singers gone?
They're here now.
Yeah.
Check, check.
Two different mics, hand mics.
Mic check. Nitya, you're ready? Okay. Good morning, everyone. Good morning. We'll start in another few minutes. Once again, good morning, everyone.
Clear. అదే బాగుంది అంటే రెండు ఒకటే ఆడియో లెవెల్స్ అంటే ఏదో 510 వాల్యూమ్స్ ఉంటాయి 95 అంటే 100 అలా ఉంది నాకు అయిపోయింది ఓకే సెండ్ చేపిస్తాను
We request the audience to please be seated. Everyone. Good morning, everyone. The program is about to start in another few minutes. We request all the audience to please be seated. All the audience are requested to be seated. We'll start the program in another 2 minutes. We request all the audience to be seated. Volunteers, please be alert, and we request all the audience to be seated. Good morning, everyone. A performance of Indian classical dance is a mesmerizing start of a purposeful journey through tradition, culture, and narration. With intricate footwork and graceful gestures and expressions, dancers breathe life into epic tales. Each performance is a celebration of heritage, discipline, and timeless beauty of Indian artistry. Now, let us invite Team Nitya Tarang to invoke divine blessings to the welcome dance.
Mama papa nini dim risagare tagadim
dhimi tagadari gidadim
tagadimi tagadari
to piya se nana ladai re main to piya se nana ladai re main to piya se nana ladai re main to piya se nana ladai re khardari gawari kahe so gaye khardari gawari kahe so gaye main to piya se nana ladai re main to piya se nana ladai re main to piya se oh main to piya se
Thank you so much, Team Nitya Tarang. That was an amazing welcome. We request all the guests to please occupy the chairs in the first row of the auditorium.
Check. Check, check.
Ladies and gentlemen, renowned guests, esteemed delegates, research scholars, attendees, and dear students, a very good morning to you all. I, Bhargavi,
And I, Nandini,
welcome you all to the inaugural ceremony of the International Conference on Applied Mathematics and Advanced Data Analytics for Industry 5.0. ICAMADA 2024, organized by the Department of Humanities and Sciences and CSE Cybersecurity, Data Science and AIDS, VNRVJIET Institute of Engineering and Technology in collaboration with Indian Society of Remote Sensing, Andhra Pradesh and Telangana Society for Mathematical Sciences, and Cybersecurity of Excellence. We are delighted to have you all here today as we embark on this journey of exploration and innovation in the realm of Industry 5.0.
Today marks a distinct milestone as we gather here to delve into the intersection of applied mathematics, data analytics, and the ever-evolving landscape of Industry 5.0. With the theme of bridging theory and practice, ICAMADA 2024 promises to be a platform for insightful discussions, groundbreaking research, and fruitful collaborations. Before we proceed further, let us take a moment to extend our heartfelt gratitude to all the individuals and organizations whose unwavering support and dedication have made ICAMADA 2024 possible.
We are honored to have with us today esteemed personalities who have dedicated their lives to advancing knowledge and fostering innovation. Without further ado, let us commence the program by inviting the guests onto the dais.
It is my delight to invite an admirable academician and administrator who consistently strives for the growth of the Department of Humanities and Sciences. Her commitment to the holistic development of the department is truly commendable. I am pleased to invite the head of the department and conference chair, Dr. T. Jayashree, Professor of Mathematics, to grace the dais. Thank you, ma'am. I now take privilege to invite a truly remarkable individual who plays a key role in shaping the destiny of our institution. I am talking about none other than our esteemed director. Let's give a thunderous round of applause as we welcome our Director Advancement, Dr. B. Chennakesava Rao.
Thank you, sir. Let's now welcome the person who has been a guiding light for our institution, a visionary leader whose commitment to education has inspired us all. Ladies and gentlemen, please join me in welcoming our beloved principal, Dr. C.D. Naidu, to the dais. Thank you, sir. I am privileged to extend a heartfelt invitation to the General Secretary of VNRVJIET, a man with wealth of knowledge, Engineer J. Seshagiri Rao Garu. Thank you, sir. Your presence here today enriches our event profoundly.
I would like to extend a warm welcome to Lieutenant General Girish Kumar, Advisor to the Ministry of External Affairs. Your presence on the dais would greatly enrich our ceremony. Thank you, sir.
Lieutenant General Girish Kumar, VSM, has served as the Surveyor General of India and holds 40 years of experience in surveying, mapping, geospatial policy, and GIS applications. Previously, he was the Additional Director General of Military Survey at Army Headquarters. He is involved in national and international forums representing India in international, bilateral, and multilateral discussions on surveying, mapping, and geospatial data management. He has received prestigious awards including the Vishisht Seva Medal, the Chief of Army Staff Commendation Card, and the Atal Bihari Good Governance Award 2021. Currently, he holds multiple advisory and leadership positions. Please join me in welcoming Dr. Ritu Karidal, Senior Scientist in Indian Space Research Organization, to the dais. We request you to grace the dais, madam.
Your presence is truly appreciated, ma'am. Dr. Ritu Karidhal is a senior scientist in Indian Space Research Organization with a key role in realizing the Mars Orbiter mission, which created history being the mission to reach Mars in its first attempt. She is the mission director of Chandrayaan-2 and integral part of Chandrayaan-3 team and worked for many prestigious missions of ISRO. Dr. Ritu Karidhal is a keen academic who published more than 30 papers in international platforms. She received awards such as Young Scientist Award in 2007 by Shri Abdul Kalam, Lakshmipati Singhania Young Leader Award in Science and Technology by Honorable President of India, Srimati Draupad Murmu in 2023, UP Gaurav Samman 2023, etc. Currently, she is holding the responsibility of Group Director of Mission Planning and Operations Group.
We are blessed to have the Rocket Woman of India here with us. Thank you, ma'am.
We are honored to have Professor Arun Kumar Pujari, Advisor and Professor Emeritus, Mahindra University with us today. Please join us on the dais, sir.
Professor Pujari joined as advisor and Professor Emeritus, Department of CSE, Mahindra University in November 2020. He had an extensive tenure from 1985 to 2019 at the School of Computer and Information Sciences, University of Hyderabad. Before joining the University of Hyderabad, Professor Pujari served at Jawaharlal Nehru University, New Delhi, and the Otto Carter Cell Survey of India. He has completed his PhD from IIT Kanpur and went on to play pivotal roles in various advisory capacities, contributing to decision-making committees of organizations such as DST, UGC, AICTE, DOS, and more. He has served as a member of governing bodies of several government institutions and corporates. His contributions at the University of Hyderabad include serving as the Dean, Head of Department, etc. With over 100 publications to his name, Professor Pujari has also supervised more than 20 doctoral students. I am now privileged to invite Dr. K. Srinivas, Deputy Director, NRSC, onto the dais.
Thank you, sir. Dr. K. Srinivas completed his post-graduation in agriculture, specializing in social science, and joined NRSA in the year 1989. He was awarded PhD in remote sensing from JNTU, Hyderabad during the year 2002. Over his renowned 30-year career, Dr. Srinivas has spearheaded numerous projects focused on the application of geospatial technology in soil resources, land use, agriculture, and land degradation. His expertise encompasses the utilization of digital and visual techniques in natural resource monitoring studies with this focus on advancing digital classification techniques through innovative multi-channel, multi-temporal, and multi-sensor data sets utilizing cutting-edge classification algorithms. Dr. Srinivas has extensive experience in harnessing satellite and aerial data from optical, SAR, LiDAR, and thermal sensors for in-depth studies on natural resources. Dr. Srinivas is actively involved in national committees addressing soil health cart, land degradation, environmental accounting, and land records, modernization, and disasters. Currently, he is working as Deputy Director for Remote Sensing Applications at National Remote Sensing Center, Hyderabad. He also serves as the Chairman of Indian Society of Remote Sensing, Hyderabad chapter. He works on enhancing the use of satellite remote sensing through organizing conferences, workshops, and engaging in student-centric initiatives. Let's now invite Dr. Sriram Birudavalu, CEO, Cybersecurity Center of Excellence, onto the dais.
Dr. Sriram Birudavolu has been a senior management executive with over 2 decades of global experience in the IT, ICT, telecom industry with an excellent track record. He has expertise in building high-performance organizations that enable and catalyze business and innovation strategy. He is a C-level advisor and technology startup mentor. Sir holds a PhD in Open Innovation in ICT, conferred by Indian Institute of Foreign Trade in 2016. Also, he has a Master's in Computer Science and a Bachelor's in Electrical Engineering. He has published a book titled Business Innovation and ICT Strategies with Palgrave Macmillan, Springer Publications in December 2018. He is currently the CEO of DSCI's Cybersecurity Center of Excellence, incubating startups in cybersecurity and privacy. May I now request Professor D. Srinivasacharya, APTMS SMS President, NIT Warangal, to grace the dais.
Professor D. Srinivasacharya obtained his MSc degree with distinction and PhD in the field of fluid mechanics from Regional Engineering College, Warangal, presently NIT Warangal. He joined the Department of Mathematics at NIT Warangal in 1999. He has successfully guided 22 PhD students for their doctoral degree, guiding 50 PG dissertations for their master degree at NIT Warangal. He has executed 8 major research projects funded by MHRD, CSIR, SERB, and DST. He has recently been awarded a Spark Research Project. The results of these projects contributed significantly to the new knowledge and resulted in a good number of publications with an evidence of large citations. He has authored 230 papers in various reputed and peer-reviewed international journals.
It's time to invite Dr. Ravi Sadasivani, AGU nominated scientist and research professor from Mississippi University. With over 25 years of expertise in remote sensing, GIS, and technology-driven policy formulation, Dr. Ravi is a distinguished remote sensing and data scientist holding both an MS and PhD from the USA. His career reflects a relentless commitment to innovation, utilizing advanced technology to transform data into impactful insights that significantly influence scientific research and policy decisions. From a policy perspective, his work provides decision makers with critical information contributing to the policies addressing global issues. Collaborating within multidisciplinary teams, his leadership has resulted in groundbreaking research disseminated through publications and reports. His work has secured multi-million-dollar academic funding from federal agencies and industries in the USA and India. Notably, he received the US Presidential Citation Award in 2005 for joint efforts in the rescue during Hurricane Katrina, leveraging geospatial technologies. Thank you, sir.
Today, we embark on a journey of enlightenment and partnership. Before we commence, let us symbolize the brilliance of knowledge with a traditional lamp lighting ceremony. This signifies the pursuit of wisdom in our endeavors. I request all the dignitaries to join together on this auspicious moment as we ignite the flames of learning and innovation, illuminating the path to a brighter future.
Thank you all. May I now request Ms. D.B. Sri Saranya and R. Tejaswini to sing a prayer song.
वातापि गणपतिं भजे हम वातापि गणपतिं भजे हम वातापि गणपतिं भजे हम वातापि गणपतिं भजे हम वारणास्यं वरप्रदं श्री वातापि गणपतिं भजे अहं भूतादिसं सेवितचरणं भूतादिसं सेवितचरणं भूतभौतिकप्रपञ्चभरणं वीतरागिनं विनतयोगिनं वीतरागिनं विनतयोगिनं विश्वकारणं विघ्नवारणं वातापि गणपतिं भजे अहं भूतादिसं सेवितचरणं भूतादिसं सेवितचरणं भूतभौतिकप्रपञ्चभरणं वीतरागिनं विनतयोगिनं वीतरागिनं विनतयोगिनं विश्वकारणं विघ्नवारणं वातापि गणपतिं भजे अहम्
Thank you both for creating pleasant vibes all throughout the auditorium with your melodious voices.
At the outset, let me brief you about VNRVJIET. VNRVJIET Institute of Engineering and Technology, established in 1995 by eminent educationalists, industrialists, and businessmen as a part of non-profit organization Vijnana Jyoti Society. It has earned a brand name in engineering education scenario. VNRVJIET began its journey with a humble intake of 220 students and 20 staff members. It has grown to become a premier autonomous institution offering a wide array of UG and PG courses in engineering with an intake of 2,000 students and more than 600 staff members. It is aiming to become a university soon. Since its inception, the institution has been committed to providing quality education with innovative learning, teaching and learning practices, striving for excellence through the essence of quality and integrity.
The institute has been accorded an autonomous status for 10 years by the University Grants Commission from the year 2018-19 to 2027-28, besides being recognized as an institution with potential for excellence. It is also accredited by NBA, NAC with A++ grade to its credit. Besides imparting world-class education, VNRVJIET engages students meticulously in co-curricular and extracurricular activities to ensure all-round development of the students. With all its distinctiveness and incessant efforts to providing world-class holistic education, VNRVJIET becomes renowned in providing outstanding campus placements.
Over to Ms. Madhura and Ms. Sansita.
Thank you, Ms. Bhargavi and Nandini. To kickstart today's ceremony, let us warmly welcome Professor T. Jayashree to deliver the welcome address and set the tone for ICAMADA 2024.
Good morning, everybody. Distinguished delegates, ladies and gentlemen, boys and girls, welcome to the International Conference on Applied Mathematics and Advanced Data Analytics for Industry 5.0, jointly organized by the Department of Humanities and Sciences Mathematics and the Department of CSC Data Science, AIDS, and Cybersecurity. On behalf of the organizing committee of ICAMADA, that is the short form for the international conference, I'm extremely glad to welcome everyone to this much awaited conference. I welcome our beloved principal, Dr. C.D. Naidu sir, our director, Dr. Chennakesar Rao sir, Director VJM, Dr. P.D. Raghunath sir, Engineer Shashgir Rauga sir, General Secretary Vignan Jyoti, Professor Arun Kumar Pujari, Professor Emeritus Mahindra University, Dr. Sriram Biradavolu, CEO, Cybersecurity Center of Excellence, Dr. K. Srinivas, Deputy Director, Indian Society for Remote Sensing, Dr. Ritu Karidwal, today's guest and invitee, special invitee, and Dr. Ravi Sadasuvani sir, who's the professor from Mississippi State University. So at the outset, I would like to thank our management and all the distinguished guests, the participants, speakers, and sponsors for being here today with us as part of this conference. We've received an overwhelming response to the call for papers, and today's conference has around 270 participants from all over India and speakers from around the globe. This makes our conference truly international. The theme of this conference is Mathematical Synergy, Pioneering Industry 5.0 with Advanced Data Analytics and Innovation, where our exploration intersects with applied mathematics, advanced data analytics, and cybersecurity within the dynamic landscape of Industry 5.0. The theme underscores the role of innovation as a central tenet of Industry 5.0. The conference highlights the convergence of applied mathematics, advanced data analytics, and cybersecurity within the dynamic landscape of Industry 5.0, steering our quest for innovative solutions and catalyzing progress in this rapidly evolving domain. Math-Tech Synergy encapsulates our collective vision of harnessing the power of mathematical innovations and cutting-edge technologies to address the challenges and opportunities presented by Industry 5.0. It signifies the harmonious collaboration between mathematical principles and technological advancements to drive real-world solutions and propel industries forward. The main aim of the conference is to leverage the mathematical synergy and advanced data analytics to pioneer the transformation of industries towards the vision of Industry 5.0. Mathematical synergy underscores the indispensable role that mathematics plays in shaping the trajectory of science and technology. Mathematics, as the universal language of innovation, forms the foundation upon which advancements in data analytics, artificial intelligence, and Industry 5.0 are constructed. Through the lens of mathematics, we unravel the intricacies of modern technology and pave the way for groundbreaking innovations. The conference serves as a nexus for exploring the mathematical challenges inherent in the Industry 5.0. From intelligent technologies to transportation engineering to cybersecurity, we stand at the forefront of shaping the future of our evolving technological landscape. Our aspiration transcends mere productivity enhancement, and we endeavor to cultivate a symbolic relationship between humans and technology, wherein innovation seamlessly aligns with human needs and capabilities. Through the next few days, the conference will serve as a platform to exchange ideas and explore the latest developments in mathematics and advanced analytics. Through this conference, we aim to foster interdisciplinary collaboration between mathematicians, data scientists, engineers, and industry professionals. We also aim to showcase innovative research and practical applications that demonstrate the impact of mathematics and technology on Industry 5.0. We also aim to discuss emerging trends, challenges, and opportunities in the field of applied maths and data analytics. And further, we aim to inspire and empower the next generation of mathematicians and technologists to a positive change in their respective fields. We have curated an exciting agenda for the conference featuring keynote presentations, panel discussions, technical sessions, and interactive workshops. Each session has been carefully designed to explore different facets of math-tech synergy and provide valuable insights for the participants. I'm sure that the selected topics will provide the participants with a wealth of information and many opportunities for discussions and result in an exciting exchange of information on current developments and applications of mathematical principles to optimize data analysis processes, extracting meaningful insights from complex data sets, and further explore potential opportunities for innovation within industrial settings through the integration of mathematics with data analytic techniques, such as machine learning, predictive analytics, and so on, to optimize the manufacturing processes, supply chains, and resource utilization. I hope all the participants will have a successful and enlightening conference. Thank you all.
Thank you, ma'am, for those inspiring words. Your dedication and vision are truly the foundation for this remarkable gathering.
Ladies and gentlemen, it is now time for the official inauguration of ICAMADA 2024. I request all the dignitaries to please officially inaugurate the conference.
Yeah, now the event is open.
Now, I request Engineer J. Seshagiri Rao sir to officially declare the inauguration of ICAMADA 2024.
Organizing a conference of this scale and significance, as we continue our journey through the realms of knowledge and discovery at ICAMADA 2024, we pause to celebrate another milestone in our collective pursuit of excellence. Before us lies the launch of Souvenir, a testament to the dedication and resourcefulness of numerous minds that have contributed to this conference. Put your hands together as our dignitaries release this embodiment of inspiration, marking yet another chapter in our quest for innovation and enlightenment.
Now, I would like to invite Engineer Dr. J. Seshagiri Rao sir to make our opening remarks. The General Secretary of VNRVJIET.
Good morning, everybody. Can I hear it much louder? I think we are early in the morning. Where is the energy? We all had a good breakfast, I think. Come on, where is the energy? I need this. Once more, good morning, everybody. Good morning, that's much better. Thank you all. I now take this privilege and hereby declare the commencement of the conference, effective just now, and followed by all the sessions for the next 2 days. Wishing you all the best. Thank you. Again, once more, good morning to all of you. I am asked to give the opening remarks. First of all, I would like to say, because I am the General Secretary of VNRVJIET, it is my duty to first inform all of you what is VNRVJIET. So, of which this VNRVJIET is one of the constants. VNRVJIET is a society promoted by like-minded industrialists and other professionals to serve the society. Under this, we have engineering, management, arts and science, agriculture, schools, and polytechnic. So all these institutions come under VNRVJIET, of which VNRVJIET is the main constant. And right now, all of you are sitting in VJIM auditorium. This is VJIM campus. VNRVJIET is in the other side. So that's a little bit about VJ. Now I am very happy to be here because it's a very special subject being done by the Department of Humanities as well as CSE, data science, AI and all that. Most important is the data science and cyber security. See, these two go together. You have a lot of information, data and all, how properly to be used. The cyber security helps you in controlling all that, accessibility and all that. I know a little bit about data science is, if you are in a consumer industry, and let's say you are talking about Hindustan Lever or a Procter & Gamble or somebody who is producing lot of varieties of products and distributing it across the world. But one thing all of you should know, that one area accepts one kind of a product, and the reason why they produce so many number of soaps or so many number of pastes which are, see, different tastes require different areas and accept different tastes. Now that is where the data science comes. For a company, I am talking from industry point of view, how it would help us. See, I am from an industry, so I should know what is required, in which area, when it is required, what is the, and especially in India, we are bound by so many cultural factors, festival factors. So your product reaching at a particular time, a product is in demand, sometimes it is not there. So you will have to understand, graph all these things. And how it helps is, At a retail level, when you are buying, your data is entered. So that is again taken back and analyze the data, which area is buying which product and what period of the year. And accordingly, with all that analysis, data analysis, it helps me in actually producing what is required for the market at a particular time. That saves me a lot of inventory cost, holding cost, and as a manufacturer, it might affect me on my bottom lines. 100% it will affect, because I'll be saving. I don't want to hold a product which is manufactured and lying in my godown, not being distributed. So I have to match the requirement of the market, all these things. So these are all the smallest things I'm talking about, but there are a lot of other things. As an individual, your data is always there with this now. So cyber security plays a big role there. Availability of data is everywhere, but how it is being used, how judiciously it is being used, and how the policy making prevents it from misusing the data. All these are issues, and I am happy that we are all gathered here. And the basic requirement for all this analysis and everything is the mathematics. Unless you know what is mathematics, all these things will be going over your head. All the data will just go over your head. You won't understand what is it. So it's a good thing that we are all combining together and doing this session. And I hope all the participants, and I have met a lot of the speakers and other dignitaries, and I am very, very confident that their inputs, their sharing of their experience, their sharing of the information would benefit all of you. Please utilize that, and I am sure you will all benefit from the whole session for the next 3 days. So wishing you all the best, wishing the conference all the best, and welcoming all the participants. Thank you all.
Dear sir, thank you for throwing light on the practical and utilitarian aspects of the subjects which are the heart of the conference. Thank you, sir.
Now, I would like to invite our principal, Dr. C.D. Naidu, to address the crowd.
Good morning, all of you. Dignitaries on the dais, and scientists, professors, and eminent speakers are all on the dais. So thank you, all of you, for taking up your time and coming over here to inaugurate this conference on this auspicious day. So the objective of this conference is to foster knowledge sharing and knowledge exchange, highlighting their innovations and encouraging their collaborations. These are the three main objectives with which this conference is being conducted, so that exchange of ideas and collaborations will happen on these 3 days. I thank and congratulate the Department of Mathematics and Data Science departments conducting this workshop and inviting a lot of research papers being presented in these 3 days in different tracks in different rooms after this inauguration session. So it will be a great learning in these 3 days. I hope all the participants and the speakers and also have a great learning in these 3 days. I wish you good luck for this conference in these 3 days, and great learning will happen in these next 2 days, 3 days. Thank you.
Thank you, sir, for your insightful remarks. Your leadership and guidance have been instrumental in shaping this conference.
May I request Lieutenant General Girish Kumar to please share your perspective, sir. Yes, sir.
Good morning, everyone. Namaskar. distinguished dignitaries on the dais, of the dais, guests, participants, faculty members, dear students. I'm really very happy to be part of this conference because so far we have been attending only application-oriented conferences, GIS, its application, various problems being faced. But somehow or other we lost the basics of the science, geospatial science in between. And today the theme of the conference is very relevant, and as India goes towards Atmanirbharta, I think this kind of conferences and this theme is very, very relevant. Now, since I have headed the department which is 257 years old, so definitely I'll connect all the dots that how it started and where we are and what are the challenges we are facing and what the conference we expect from the conferences, that how they will guide us and provide us the solutions. We all know that first world map was sketched based on a verse in Mahabharata. And after that, during Mauryan period, cadastral survey was done. Since I have only 5 minutes, so I'll be really rushing very fast. So I don't want to take time of other dignitaries. So cartography has written evidence of about 2000 years. Then finally came Raja Todarmal in 1580. He standardized the measuring units. I don't know whether many of you know it or not, that Ilahi Gaj was standardized, which was 41 fingers, about 29 to 32 inches. And 3600 Gaj was 1 biga. So you can imagine that measurement started from 1580 onwards actually. He introduced various system of revenue management, because that time what was geospatial? Geospatial was nothing. It was mapping, and basically the purpose was for tax and revenue collection. How much a person owns the land and how much he is growing, tax was on that. Where he is living, that was not taxable. So they started the institutional work, the system of Patwari and revenue officer introduced by him in 1580. And it continued with some modifications by various, the British government also, then Indian government also, but the system continues. You can imagine that person who thought in 1580 and till today we are following almost the same system of Patwaris. But this was also not very scientific survey, because of course he standardized the measuring tape, bamboo joined with iron hooks so that stability remains. Then in 1802, the Great Ark expedition was started. I don't know whether people have, many of you have read about the Great Ark. This was the first scientific survey which was started in India. Great Ark was a 78-degree longitudinal arc which was measured at that time, started in 1802, took 52 years to complete the India for scientific precision mapping. Now imagine in 1802, somebody visualizing that we need to cover entire India and the subcontinent. It was not only India, but the entire subcontinent also. That this expedition was started. No communication, no modes of transport, nobody knows where we are going, nobody knows the terrain, big rivers, thick jungles, or so many problems, but still they managed to continue for 52 years. And in 1854, they completed the entire India. Now, why this story I am narrating is that mathematics behind this was the basic of scientific survey. Imagine somebody sitting in India measuring the height of Everest in 1854, accurate to few inches, which even today's modern technology is not able to discount that. So that was the contribution which our predecessors have given to us, and when they really working on the basic science. From 1854, we continued till 1995 on the same system. This was called average system. GT stations were established. Benchmark was established for carrying out the accurate measurements. Celestial observations, star observations were done. When we joined service in 1980s, that time we also used to do the star observation, and a lot of mathematical equations used to be there. Big forms were there. But slowly and slowly, as the technology improved, the science improved, the solutions were provided, and slowly now we are converging into small computers, small mobile phones. But people really don't know what are the basics behind it. And still, we are facing so many challenges. India had a big advantage as far as the science is concerned. But somehow or in between, I think we lost that enthusiasm to carry on with the science. 1995, when GPS came into existence, that time people were very excited. Now the positioning will improve. In India also, we started following the GPS in 2005 when the new national map policy was announced. Under that policy, we again revised the national reference framework. The integrated geospatial reference framework for any country is very, very important foundation layer. Without this, the scientific surveys or accurate surveys are not possible. So in 2005, again we devised the new reference frame, that is WGS 84, based on that, which is a global one. And once we are done with that, now we all know the problems of the GPS. Suppose somebody turns off the GPS, then what happens? Then entire your system goes for 6. So it means slowly and slowly we need to consider that terrestrial navigation system also. We have existing GPS, Galileo, GLONASS, Baidu, Indian Navic also is picking up, Navic is picking up, and I'm sure that in a few years Navic will be fully operational. Now, if you really see that what are the limitations of this space-based technologies, when we use GPS in a standalone mode, it gives us accuracy of about 8 to 10 meters. This accuracy can be improved by using a DGPS by a few centimeters, but you need 24 hours observation and data processing also. Okay, then we move further. We can use an RTK method, which gives us accuracy of few centimeters, immediate solution, but then limitation is of 10 kilometers. Now, how do we improve our observation system, positioning system? Then in India, what we have done, we have established a CORS. It's called Continuous Operating Reference Station Network. When we use this network, then we can achieve accuracy of few centimeters in a minute, because we have created an infrastructure in India which is about 50 to 80 kilometers apart, like we have our mobile towers. So we don't know where the mobile tower is located, but I continuously get my mobile signal. So I keep moving. So I am not interested where the tower is there. But earlier the conventional way, you need to have GPS, you need to put it at 2 places. So that also now it has been eliminated. Now the continuous operating reference stations are there and they are connected to a network. Again, still we are talking of the centimeters. We have not moved to the millimeters. So now this new generation, the coming generation has to think that how we improve our positioning system from centimeter. Earlier we were talking of meters, then decimeters, then centimeters. Now we need to work on millimeters. So VLBI is one of the solution, very long base interferometry, which will provide us millimeter kind of accuracy. Because tomorrow you are going to move towards automatic moving vehicles, then decimeters will not work, centimeters will not work. You need to have very, very precise positioning infrastructure. So we need to work on VLBI for our millimeter accuracy. Now this again gives us only XY. The Z comes from geoid. Now the geoid, how it has been evolved in India, in 1907 we first did the sea level measurements. Everybody must be knowing what is the height of this place. We know mean sea level. Now, from where this mean sea level is coming, nobody knows. So we in India, what we did, we carried out the observation on port, and based on that, benchmarks were created. But somehow, because of the lack of data processing capabilities, mind you this word, data processing capabilities, which now again the theme of the conference is, we could not process the entire data for the entire India. So no adjustments could be done. So in 2018, what we did, we from 1907, then 2018. 2018, we revised our vertical datum also. Based on 8 boards, 4 on the eastern coast, 4 on the western coast, we carried out the observation, and we evolved a mathematical model to measure accurate heights. Now, we all know that the shape of Earth is not spherical, but the GPS considers it as spherical. So what height we get from GPS, they are ellipsoidal heights. They are not based on the gravity observations. Now, how do we convert this ellipsoidal height to orthometric height using technology? So we need to have a geoid model in the country. Again, it is a mathematical model which we need to work. So far what we are using developed by other countries. But I request this conference to take a note that we need to work on geoid model, mathematical models, which will be used in India. Now what it does, it establishes a relationship between the orthometric height, that is the gravity height, and the ellipsoidal height. So when you put a GPS somewhere, in any case you are getting XY. The Z also you can get very accurately to 10 centimeters. So it means if we have a very good mathematical model, then this accuracy again can be few centimeters. Now we are talking about the 10 centimeters, but it should be few centimeters. Why few centimeters are important? We see that lot of flooding is taking place in our cities because we have no accurate data for these cities. The digital elevation model is missing. So these are the few connecting dots which you need to work. Now we like the data acquisition. Data acquisition is one of the important input for the geospatial work. Earlier we used to do everything on a blank paper. Like engineering students, they must be knowing that okay, we theodolite, plane table. From there we moved on to the satellite, aerial based data acquisition. Now we have the drone based data acquisition. In 2019 we started in India also drone based mapping. Now these drones are giving us so much of data that computing has become a bottleneck. If we can find good solution which are fast enough, because the data being acquired by a drone is very, very heavy. You can see now you read everywhere whether it is a warfare or development work or medical or educational work, everywhere drone is being used and it is going to increase. Still we are in the beginning only. Then also we have about a few thousand drones only. But when it goes to lakhs and lakhs and lakhs of drones, the amount of data being generated by them, the computing power, the storage power, the capabilities and analytic power, what we are going to need is going to be very huge demand. So this because universities, you have a good brain, young mind. You are not concerned what somebody has done. You keep thinking, you keep evolving and keep working on the new challenges and give the solution to country and for national development, for economic development. And time is very less, story is very big. We can continue because other speakers are also there. So at the end, I just want to request this conference that please continue your effort in the coming years also. Don't lose this steam and don't go by the solutions which are already commercial solutions which are already available in the market. Train young minds to provide geospatial solutions in all the aspects, whether it is a data acquisition, data processing, data analytics, data management, data accessibility, cyber security, all these challenges the country is facing, and we look forward for very good solution from all of you. I really thank the organizers for inviting me and giving me this opportunity to share my experience. and request all of you that what the country needs in future for economic and social development. Thank you so much. Jai Hind.
Thank you, sir, for sharing ideas like the practical implication of epics in war strategy, aspects of cartology mapping, importance of scientific inquiry. They play an instrumental role in modern navigation. Thank you.
Now, we are delighted to welcome our beloved Director, Advancement, Dr. B. Chennakesava Rao sir, to share few thoughts.
Good morning to all of you. Namaskar, Swagatam, Suswagatam to all of you for this international conference being conducted at VNRVJIET. Respected dignitaries on the dais, of the dais, deans, heads of departments, faculty members, non-teaching staff, delegates from various institutions, eminent speakers and experts from various institutions across the globe, and my dear students, ladies and gentlemen, it gives me great pleasure once again extend warm welcome to all of you for this 3-day international conference on ICAMADA 2024 being conducted here. So first of all, I think I would like to congratulate the Department of Mathematics and Humanities and as well as Data Science, Cyber Security and AIDS together organizing this international conference in association with that is APTSMS, the president is there on the dais, and Cyber Security Center of Excellence, Sri Ram Garu also is there on the dais. Sir, without your support, it is not possible to organize this international conference. Please, all of you, give a big hand to all these two people for making this event here at a grand success. So today, I think everybody is talking about computer science, that is AI machine learning. Without algorithms, I think it is not possible. And cyber security, IoT, quantum computing, you name any technology, I think all those technologies are made available at VNRVJIET, sir. We have already included in our curriculum, and we are also conducting conferences and workshops in these emerging technologies also. In the ever-evolving landscaping of the digital era, data analytics has emerged as one of the important activity. And in this connection, I think we have decided that the theme is advanced data analytics in addition to the cyber security and applied mathematics. So applied mathematics is the mother of engineering. I think as you're all aware, without mathematics, I think there is no engineering. So I would like to thank all the contributors, especially for mathematics. Especially I think Pujari sir is there here. So many people, I think they have done extremely good job to improve the various mathematical model to give the solutions to the engineering problems. So today, I think even though AI, that is artificial intelligence, is started in 1953, not now actually, but because of advances in computing facilities, I think it has come limestone in this particular era. So in this connection, I think each one of you have to provide the quality solutions by using various emerging technologies like AI, machine learning, and deep learning, and cyber security. I think these are all the two which are very, very important. I think each one of you have to explore in these particular technologies and provide the solutions. So the skill sets that are required for the data analytics are, you have to learn Python, MySQL, Excel, Power BI, Tableau, and data analytics tools. So I request all the students, because the student community is also there here. So the India has demographic dividend. I think you're all aware the average age is 27 years. I think, so this group definitely will explore the possible solutions to the society. So definitely I think each one of you, you have a potential. And I think this is the one platform where I think you can interact with the eminent speakers we have invited for this conference. So I think once if you can interact with them, I think spending 1 hour with eminent speakers all, I think definitely you're going to learn and enrich your knowledge in the particular field. So the challenges that which we are facing as and today in data analytics are, so the challenges of data analytics in research. So reproducibility issues, I think each one of you have to think over how to solve these problems. Then dealing with the big data, I think everybody, I think you're all aware, you are creating the huge database. So one is the data creators and the second one is the data users. So you're all creating the data. So how you're going to manage this data? So you need to have a big data analytics. So data privacy, so that is also very, very important. I think security point of view, how you're going to provide the data privacy. And ethical considerations, I think especially, so nowadays I think everybody is copying the data without mentioning the data creators. I think in this connection I request all of you, please you have to follow the ethical considerations also while designing the architectures. Interpreting complex results, so these are some of the challenges in research, especially in data analytics. Challenges of data analytics in business. I think already our General Secretary rightly pointed out that aligning with the business goals. When you're going to set the goal, I think you have to aligning with that particular business goals. And real-time analytics that is to be done. And scalability issues that are very, very important. And change management and cost management. So these are all the issues, I think, how quickly you're going to change your technologies, how quickly you're going to adapt the technologies, so that makes, I think, decision making properly. Challenges of data analytics in auditing, so especially in case of the auditing, so huge data you're going to monitor, so naturally I think you need to have a, so ensuring data accuracy in auditing. These are the challenges that they're facing. Regulation compliances, fraud detecting, especially when you're going to detect the fraud, so I think you need to have some ethical values also. Integrating with the traditional auditing processes and continuous monitoring of the data. So these are some of the challenges of data analytics in especially auditing process also. So I request all of you, please try to discuss all these issues, especially in case of the data analytics, and what are the solutions that you are going to provide, because the society is looking for quality solution and economical solutions also. It should be affordable to purchase that particular solution. So in this connection, I request each one of you, here we have a great eminent personalities, both mathematicians as well as the data engineers. I think it is your duty to discuss all these issues and try to provide the quality solution to the society. I hope you are going to enjoy this day. I wish you all good luck. All the best. Thank you.
Thank you, sir. Your remark on applied mathematics being the mother of modern engineering rings true well in the current environment. Mathematics coupled with AIDS and cybersecurity equips modern engineers to solve problems and conduct effective research.
May I now request Dr. Ritu Kharidhal to address the gathering. Please join me in welcoming her.
Good morning all. Dignitaries on the dais, esteemed guests, faculty and students and young scholars. First let me thank ICAMADA and VJIT, VNR to invite me here and be able to participate in this conference of mathematics covering the topics on mathematics, data science, data analytics and cybersecurity. So first, I thought maybe once, I just requested Madam Vijayashree to just allow me some more time, because I really wanted seeing you so many bright minds and young scholars to really share what has gone, the challenges and the accomplishments of our missions which we talked about so much. You would have heard just, on the periphery, like we have achieved this success, we could go to moon, we could go to Mars. But the role of mathematics, the role of data science, how that has really helped to accomplish such missions. So if I am allowed, maybe I can take some few extra minutes, and I brought some slides for the young students and scholars so that they can just go through it. Yeah, can I, yeah. Pardon? It displayed, yeah. So yeah, Just I will give this, you can change. So this, to start with, let us start journey, I can say it from Earth to Moon to Mars. Maybe in 10 minutes, I will try to finish. Yeah. So we all know that, our India has a great and ancient civilization with medical texts dating back to 800 BC. Our Indian astronomy was at its peak with under great mathematician, astronomer Aryabhatta, who figured out Earth revolved around the sun 1,000 years before the Europeans did it. And then, yes, we had a gap. Then we made a fresh start after independence in our Indian space program. The story goes back to 1960s under the great physicist, Dr. Vikram Sarabhai. You can see these are few of the pictures, you can see the very humble beginning for Indian space program with very limited resources. I need not to say what this picture speaks out. So yes, the beginning was very humble, but then in 1975, we had our first satellite launched, Aryabhatta. Later on, we continued our efforts to to work on many sophisticated rockets and satellites, culminating into our first moon mission, Chandrayaan-1. Chandrayaan-1 mission was so important and was had such a very historical, there was a historical finding which actually the instruments on the Chandrayaan-1, it could detect the presence of water on the lunar surface for the first time, So this was the we can say, the discovery of water on moon was really done by Chandrayaan-1 first time. Yes, after this big achievement, we had to go to our next neighboring planet, that is Mars, But, you will ask why we need to go to Mars, why we need to go to moon. It is like, there's so many unanswered queries, and when we talk of our future, we really talk of whether life is possible in any other planet, whether water is available, whether we can have a habitation, so many queries. So the missions are really important to go collect the data, understand it. And then also, one of the other reason, improving the quality of life on Earth itself, because, it is not the work which is done in one stream. If, for example, I will give you an example that one of the computer program which was developed for one of the space program, and when it was used for X-ray images, it did the better job at detecting the early stages of breast cancer. So this cross-pollination of fields where you do innovation in one and then revolutionary changes in others, it happens all the times. So when we work for such complicated or complex missions, the work goes on mathematics, the work goes on computer science, data science. It can also be used in other applications as application in other areas. So it undoubtedly improves the quality of life. And then, yes, the main reason to inspire the young generation of space explorers who can contribute to the growth of a growing nation, developing nation. So this was the goal behind going to moon, going to Mars. But going to Mars, first time it was, we had a mission to moon, then we had to go to Mars. Then what is important? We had to go first time out of the gravity well of Earth, Till now we had the understanding of how to how to capture in the orbit, how to rotate around the orbit, around the Earth. We had many missions like our polar sun synchronous missions or geosynchronous missions, and then also moon being a satellite of Earth itself. So we knew how to be around the Earth. But the first time we had to go outside the gravity well of Mars. So what it needed first, and when you start going deep into the space, interplanetary space, as far as you move, you are limited by the speed of light. Is it not? So any micromanagement which was possible for the missions or for the projects which are orbiting around Earth, for such missions micromanagement is not possible. For example, if you say the distance to Mars can be of the order of sometimes 200 millions of kilometers to 400 millions of kilometers. Any signal which you send there and the comeback, it may take the time around 20 minutes to 40 minutes. So what it meant we had to build a system capable of handling any anomaly, full self-diagnostics. It should be able to do self-recovery. It should be able to execute all the instructions with zero errors. Because again, any anomaly, nobody is there to correct it. The system has to correct on its own. So this was almost like a full-scale onboard autonomy. It was a first venture, for us. We had never done on that scale of autonomy. Many engineers, we had brainstorming sessions at that time, engineers from many different streams, be it electrical, electronics, mechanical, all were really doing, sitting together, understanding the problem, how to resolve it, how to draft this autonomy, how to bring it on the onboard computers. This is all what was required, It is, the role was played by each and every stream of the science and engineering to bring out that autonomy draft. And then thousands of lines of codes were written, were tested, executed, and everything was just accomplished in the time of 10 months. In 10 months of time, we were able to really get the full autonomy software implemented on the spacecraft, on the craft. And then a full mission was to be realized in just 18 months, because then, you can go next. Here. Yeah, so this was the mission, that's what I told. This is the actual mission which was to be realized in just 18 months of time. We did not have any heritage, and at that time, out of 51 missions, so the success rate was only less than 50%. Many missions failed, by NASA, ESA, JAXA and all missions, many missions failed, and no one could achieve it at the first attempt. So we were, on it, and our autonomy was ready. We could make the spacecraft ready. These are some of the systems where I will not go much into detail. The propulsion system, the communication system, everything. Hardware we adapted from our existing geosynchronous missions, but then their performance need to be perfected with extreme testing, with extensive amount of testing, so that they can work in deep space as expected. Now come to the mathematics. This is the main crux of the problem. You have to start from Earth, go to Mars, and then you have to reach to the place in that orbit. You can see, I think many students, you must be of maybe reading on the orbital dynamics, maybe of this, in the parts of maths or as a part of physics or maths. So you can see that we have to go from one orbit to the outer orbit of Mars, where the Mars and what is more important, when you go to Mars, when you go to that orbit, when you reach the upper orbit, the Mars should be there at that time. It is not just I reach here. When I reach here, if Mars is not there, it's like the satellite will just go take a round around the sun, and we will not be able to get captured by Mars. So it will be a failure. So it very precision. You can see this in this figure. You can make out the 4 planetary bodies. For like Sun, 3 planetary bodies and 1 our satellite. Sun, Earth, Mars, and satellite. This is a 4-body problem. If you are maybe knowing that this 4-body problem is very difficult to, we cannot solve it just like that. So what method we adopted? We adopted that this 4-body problem we have to convert into 2-body problem. In the sense, when satellite is very near to Earth, it can be an elliptical problem, elliptical conic section at that time. Then when it goes away from Earth, when it leaves the gravity well of Earth, and it becomes the secondary body for Sun. So it can be elliptical around Sun, and then when it goes near to Mars, it can become elliptical around Mars. So this method is called the patched conic method. First time we had to solve these equations. These full problem need to be solved. We had to understand when to launch, what trajectory to have, when it will be able to get captured by Mars. Everything first time. And yes, we had our good mathematicians, engineers who worked together and then found out the solution. Then coming to next important, this is like when everything was done, and then this is a picture where we are showing the satellite getting mated with the launch vehicle. Everything was fine, but then what happened, as engineers or as a scientist, we always try to see how to, optimize. It's a problem, your optimization problem you must be addressing. So there is one good optimization problem came to us also, how to optimize on fuel. We can't carry so much fuel as we want. So there was a big challenge, and then we had we found out that the solution exists that whenever the launcher launches the satellite, it should not inject the satellite. Usually you must be seeing when we launch from Sriharikota, the satellites are getting injected at a part where you call Mauritius, near Mauritius or over that region. Then we saw that if the launcher does not inject here near the Mauritius, it takes a long route and goes and inject near Pacific, then we can really have a good saving on the fuel. But then we did not have any ground stations over the ocean, we need to track the vehicle, we need to track the satellite, we did not have any ground stations. Okay, then we thought let us have some ships, 2 ships, antennas on the ship. They were sent to the oceans, and then, but they will take their own time to reach. And we had a very, very, very critical time window. Such missions work with the time window. If you miss the time window, you have to again wait for example, for Earth and Mars, there is something called 26 months of window, So every 26 months, you will get us opportunity to get to launch the probe with minimum fuel and reach to the Mars. But if you miss that window, again, you have to wait for next 26 months. It's not that you, today I'm not be able to complete my work, me do it tomorrow. It's not so. We don't have those type of relaxed windows to work. So everything has to be done within the tight deadlines. And then the ship, which I was telling, what happened, the ships could not reach in time, and we were just racing against the time. Our window was about to close. But then, yes, on 5th of November, our PSL, we made history when we successfully launched the Mars Orbiter mission in the orbit. So this is, again, this is a mathematical problem which you are seeing on the screen. There's a multi-slingshot trajectory. So we had, I told the optimization problem, yes, we had to optimize on the trajectory which will take to us to Mars. Then how to further, because whatever fuel we had, whatever launcher can give the energy, that energy was not enough. We had to leave the gravity well of Earth, means we need to have more and more energy to go out. So how it was possible, the propulsion system within the satellite, it was made to work. And then when this, you can see multiple slingshot we were having, and then at the, as the craft comes near to Earth, it gains the energy because of the gravity pull of Earth. And then it, around, I think, 25 days of these operations were going on. And at the end of 25th day, we had to leave the Earth and move towards Mars. This is called the Mars transfer trajectory. It's a cruise phase, and this is very, very important. If you, what is more important, when you leave this point, when you leave the Earth at this point, the direction is very important. If I leave, I may be able to leave, but if the direction is not correct, you will reach, you will go in the Martian orbit, but you will find Mars is not there at that time. So this needed 99.9% performance of all our systems, including the autonomy. So yes, we made history at that time itself. First time, many missions actually failed, either leaving the Earth's gravity or just before leaving the Earth's gravity. And ISRO made history when first time it successfully left for the Mars in the cruise phase. You can see how difficult it is here for this. I got, this example where you have just go outside and you hit a golf ball somewhere in the hole in the Los Angeles, The direction has to be so precise. The ball has to go and straight into the hole at Los Angeles. From here, if you have to hit it. And more complicating, the whole system is moving. Earth and Mars, everything is moving. In the stat system, it has to reach there. That was the intricacy, that was the pointing accuracy or for trajectory accuracy required to ensure that we achieve that. I will not go much more detail, yes. That was when we reached to Mars, it was around 650 millions of kilometer distance we traveled, we reached there, we were just 500 kilometers away. But then, 500 kilometers away doesn't mean that we have achieved the system. As per you know, when you go near to the planet, it will attract, it will, due to its gravity, your energy, the craft will increase, and it will not be able, it will just become a flyby. If I am not able to kill that energy, if you're not able to kill the energy correctly, it will not get dropped into the well of Mars. So it will again become a flyby. This was again a challenging thing. As I told you, we cannot micromanage the mission. Something is happening there, you will be able to know 20 minutes or 12 minutes later. So you can't do anything. The system has to perform on its own with inbuilt autonomy. So this was, the D-Day arrived, and yes, the Martian, we were just, all automatic sequences, they were initiated, engine started firing, but then again, 4 minutes later, the data was stopped. Why the data stopped? Because again, the geometry was such that the satellite went behind the Mars, where you cannot get any signal back to Earth. So those 26 minutes later, I remember we were all, very much excited. All eyes were glued to the screen, waiting for the data to come back. And then at 8 a.m. IST, the history was made. This picture speaks loud volumes. You can, the Mars orbiter mission successfully entered Martian orbit with many firsts into its account. As you can see, the first mission is successful in its first attempt, very economical, most economical project in the world of space science. And then it is the satellite which is having full-scale onboard autonomy. Then the most important thing, the youngest team of men and women scientists together work for this mission. Now coming to, this is a lot of data, data has been collected by our instruments on Martian orbit, from Mars orbiter mission, and I request the people, the data is so precious data, the students present here can go and get the data, this is all available, and you can do data analysis on that, you can really understand, maybe our people, physicists are working, but I feel that the young minds, if they look at the data, if they try to analyze that, they can bring out something really more which we would have not yet seen. So go to the sites, get the data, lot of data is available from Martian orbit, analyze it and try to see what can be done. Yes, after the mission to Mars, yes, we had a mission now. For any orbiting mission after that, what is important? When you orbit, then you have to really go land on it, because in future you will be talking about resource utilization, bringing some resources from some planet or moon back to Earth. So what is next mission is landing mission. The landing mission is again a much, much more complex mission than an orbiting mission. Because what is important, you are going to a planet, you are going to a place where nobody has gone till now. Every data which you have collected is from remote sensing. You can say from remote instruments you have seen. You have never visited, nobody has visited the place. To find such a place, where what we call as a landing site, where a craft can land without toppling or without having any hard landing, it's very, very difficult job. So there where the data analysis, where it played a role is we had the data from our cameras, LRO, we had the camera from JPL, we had our own camera, OHRC, that is orbital high resolution camera. All this data, we had to really analyze it, analyze in terms of the terrain, how the terrain looks like, what is the slope of the terrain, what the boulders are, hazards can be there, what is the craters available in those areas, what size of craters are there, whether do we have any place to land where we can see the lander can land without any instability. So this was a huge analysis by huge amount of data which was there, and then different dynamics. One more important point was in those areas where we thought of landing, that was first time anybody has gone to that region. It was uncharted terrain, that is towards the South Pole region of Moon. And then the main important part of it is the sun does not rise at those regions up to the overhead. Sun rises at very, very shallow angles. When sun is very shallow angle, the long shadows are formed on the surface, is it not? A small object will have a long shadow. If the shadows are so long, then we cannot generate power. You know, the craft which is landed in such a region, maybe it's a flat region, but the shadow is coming from other object. We cannot again generate power. So we had to really understand how the sun moves with whatever available GEMs were there, and then predict and then find out which day we should land and which area we should land. This was very challenging, and yes, in Chandrayaan 2 we attempted that. Everything went on well. There is a Chandrayaan 2 had an orbiter also, which is still working, which is just revolving around the moon and collecting lots of data. And then lander was there. It could not do hard landing. Then what happened? See, there is something which we had, as I told you, all sort of fault detection, everything, it was built in. But there's in any designing the system, you can build for the things which are like known unknowns. You know, something can happen. I know this can have a dispersion of 3 sigma or 6 sigma. I will build the system with those which can be robust to handle those dispersions. But there will be something called unknown unknowns. You know, so you are going to a region where you know you have done the best what you are aware of, but then there will be something which is not really available. It is not available in any textbooks or anything. You have to do experiments. You have to really find out and improve your model, improve your understanding. So that was the thing that Chandrayaan 2, really some few meters we lost, but then the data which we got from Chandrayaan 2, it really was a wealth of data, you know, which improved again so much of understanding, and then we built the improved system, and we made Chandrayaan 3 successfully landed on 23rd of August, which is called like Shiv Shakti Point. So I was, I will complete my slide. This is the next slide is not moving. You can put, yeah. So this is, you can just see, okay, I think it's not. So what I just wanted to tell, okay, let us hold here only. So this is what the recent accomplishment. Then what, as I told you, this all missions are full of, if you start from beginning, as I told, analysis, the mathematical modeling, and then the data analysis, the image processing, data processing. And this is only just starting of the full space program. It is not space program. It consists of so many other streams also. So the conference, I really request the students, the young minds who are really interested in doing real mathematics, real data analysis, go get the data which is available from these sites. We call it as a Pradhan site. Maybe we can give you what are the details. There's a Pradhan site where all these data which till now has been collected, and then it can be really used for many projects. You can have a different types of projects students can take up, and then this can be further improved on your, maybe what we have not discovered yet, you may be able to discover. So I really wish you all the very best for this conference and successfully completion of this conference. Thank you so much.
Can we please give the ma'am the standing ovation? Thank you for narrating the journey from Earth to celestial bodies like the Moon and Mars, from Aryabhatta to Vikram Sarabhai, starting at humble beginning to the erstwhile Chandrayaans. Cross-pollination across fields is the necessity of today to improve the quality of life.
Next, let's all put our hands together as we invite Professor Arun Kumar Pujari to share his thoughts.
Management of VNRVJIET, dignitaries sitting in the dais. There are many dignitaries sitting outside the dais also. Participants of the conference, other students, staff, other things. First of all, congratulations to the Institute for organizing such a great conference. A lot of people on the dais, that itself shows the power of the conference. Then a lot of people who are going to speak later on. So that itself is also showing something more about the conference. Then I asked myself, what is that I have to tell here? There are so many interesting things we are hearing, in fact, and a lot of things, but then probably I'll start with a story rather than talking this thing. All of you have seen Buddha statue in Hyderabad? Students might not have seen the Buddha statue, am I correct? People who are international guests, I request them to see the Buddha statue. It is one of the tallest standing Buddha statue. Now, to talk about this, when it was being transported, it was made in one of the villages. It was brought in a cart to the next part of the bank of the lake. And when it was being transported, it fell down the water. And a lot of people died. Do you know that? The students may not know, it is there. Then it was brought up. Now, one government was doing this, and there are oppositions also. So oppositions were criticizing that the statue was broken because it went inside the water and it was brought out. They said there are a lot of damages to the statue. No, but then there is no way, because the measurement of the statue was never done before it was brought, and hence nobody can claim what was damaged or not. Then suddenly they realized that it is necessary to measure absolutely correctly the Buddha statue, so that in future if there is a mistake, then they can do that. And they formed a team in which I was a member, and my colleagues from Survey of India, R&D were also there. And what we did is that, imagine that when it was brought and kept flat on the water surface, we have to go up to somewhere in the height, put 2 cameras to take a stereo image of that, and we had equipment in which we can manually draw the contours, and did that. Okay, that was the time. Then subsequently some other time it so happened that all of you know about a temple called Brihadishwara temple in Tanjore. It is one of the tallest temples. And they wanted a complete 3D modeling of the temple. Ministry of Culture, Government of India wanted it. Again, they formed a team, and I was fortunate enough to be a part of that. We found that the 3D details of the temple is not there. In fact, I can tell you now that 3D details of not many temples of India is still available for you to get an exact replica in a 3D printing scene. You can guess something, but you cannot get exact value of those things yet. So now question is, that time we thought of flying a helicopter and trying to take the picture. It was not allowed. Today, when I saw it today, that when I was doing this today, drones are available. So what is the summary which Lieutenant General Girish Kumar has said and Madam has said, that data acquisition has changed, had a sea change from few years back to today. You can absolutely collect the data which you could not have done it earlier by drones and other things. Do you know how Google corrects a map? Just ask people to go drive on the road, put a camera on the top, and then say that just collect the data there by GPS and other things. So data collection has become easy for them. Geospatial data collection today is so easy. The other side, people say that AI has also changed, data analysis has also changed. The way you can do data analysis today is much better than what you could have done it earlier. The one side, geospatial data collection is easy. The other side, data analysis part is very easy, very powerful. But unfortunately, I don't have a slide. I have a slide, but I don't want to project it. Every 6 months, or every 1 month, you can say, a new technology of deep learning comes up. Roughly 100 papers comes in a 2 months' time. But if you want to ask me that how many papers have come on use of new deep learning for geospatial data, absolutely zero. So geospatial data people are using deep learning only with a minimalistic way. They are still hyperspectral data, ladder data, or any other multimodal data, they call it, all of them are easy to collect. But the speed in which data collection is going, the speed in which data analytics is going, they are merging at the geospatial level is bit slowed down. And such a conference and people attending this conference, definitely a demand from people like me is to get ready to work on that area. And that's all. I don't have to say. Other people are saying what are the different technologies. In fact, I would have loved that day when that Buddha statue I was doing on Brihadishwara temple I was doing, if the technology of this kind would have been there. I am a spent force, old person, so I don't want to venture again. But what about you? Carry on, do that. This conference must address this problem, that what is the technology of data analysis, data capture, and how both can marry today in the geospatial context. That's all. And I can tell you one more thing interesting, that do you know that data technology is so accurate now that our geospatial policy of India has told Google that you cannot collect accurate data. You have to take a data which is error 5 meters away. So if you take the Google map, it is not accurate as far as Survey of India is concerned, because they have been told by the policy. So now think of, earlier it was an error-prone data that is to be corrected. Today you can absolute correct data that you can get, but you cannot give it, so that you have to incorporate an error there. So that is the kind of things that happens. But then still, why is that research is so slow? Why are you all not, please gear up for that and do that. Thank you very much.
Thank you, sir. Your insights into data collection and data analysis, the necessity for bridging the gap for applying it in the geospatial context are thought-provoking.
Next, I call upon Dr. K. Srinivas to share a few words.
Respected dignitaries on the dais, and all the delegates of this conference, students, and ladies and gentlemen. It's a very immense pleasure for me to join with you all to share a few thoughts, rather the journey what I have encompassed during the past 35 years or so. So when we started our remote sensing journey, so the people like Ritu and team, they launched the satellites into the thing. Then our job starts. Now we start acquiring the data with dish antennas, a set of dish antennas and the processing systems what we established at the Shadnagar. So once the data is received and we started processing and we start posting the data, and then we start, the scientists of the applications will pitch in to the developing various applications for the various daily needs into the thing. So if you see the journey what I saw during the past 35 years or so, so it was during the initial stages, it was very, very difficult to convince any user or any government, for that matter, for the government department, to say that the remote sensing can give this sort of an information. This is the takeaways, what you can get from the thing. Nobody used to believe that. So it took a lot of time to convince the people to see that exactly when they started actually verifying the things on the ground, then they started believing. And so then you see that there is a lot of developments that have happened, and several applications have been developed over the period of time, which comes into the various spheres of the life. It touches the various spheres of the life, starting from the mineral exploration, the disasters, water resources, like that, the natural resources, whatever there. So it has developed over a period of time, either in the temporal domain, on the spatial domain, or in the spectral domain. It's a multifold increase is there with reference to the data collection and the data collection methods and the analytical methods are developed. So now, earlier it used to be with the analysis, everything used to be in the hands of a few bunch of scientists, or a few bunch of technocrats, it used to be. Now, with the latest geospatial data, open the geospatial data, now you see after 35 years I am seeing a lot of veracity with which the data is being now downloaded by various researchers, and several interesting applications are being built by the students as well as the research community, which are especially in the universities, what we are seeing in the thing. See, last 1 year is a very, very watershed year for as far as the data utilization and the application developments are concerned. So I hope that this sort of a trend will continue, and a lot of amalgamations of the technologies are happening over a period of application domains, and interesting applications which are touching the daily lives are being developed by various researchers. And let me congratulate or thank to all the people, the researchers who have enthusiastically pitched into this wave of basically geospatial data analysis and the integration of the thing. And I expect that this peer is going to continue for with the same Philip or the improved Philip in the coming years to run. Thank you, one and all, and thanks for joining.
Thank you, sir, for discussing trends and technologies that facilitate modern living and the importance of reasons. Dear students, please look into all the problem statements as mentioned by our invitees, hoping you all to get new solutions and innovations as mentioned. Thank you.
Get ready to be inspired as we welcome our next speaker, Dr. Sriram Birudavolu, to enlighten us with his thoughts.
Hello everyone. What a pleasure and honor to be here among such distinguished guests and all of you, energized, charged students and faculty and dignitaries and friends who have come from abroad. Okay. So first of all, thank you very much VNRVJIET for making our Cybersecurity Center of Excellence a part of this journey, this wonderful ICAMADA conference. And my special thanks to Jayashree Madam and Dr. Ravi Sivadasuni, and of course Dr. C.D. Naidu, Chanachkeshava Garu, and the dignitaries, J.S. Rao Garu, General Girish Kumar, Ms. Ritu Kharidal, thank you for that very enlightening session, and Professor Arun Pujari, K. Srinivas Garu, and of course the dignitaries of the stage, the distinguished keynote speakers and the students, my dear friends. So about the Cybersecurity Center of Excellence, since I have about 5 minutes, I will keep it short. A few key points that why is cybersecurity so important? Why not just dispense with just a firewall and some antivirus and be done with it? Is it something that you need to really worry about? Okay, and just keep that aside, just a small little nuisance. Okay, well, a few facts and figures. If you take the top economies in the world, US is somewhere around $27 trillion, I think, GDP. Next comes China with nearly 19 or 20 trillion dollars. The third would be, if it were an economy, it would be cyber crimes. It is $8 trillion. And the next is Germany or Japan, both equal sized, half of it, which is $4 trillion. And of course, next is India, which is nearly becoming $4 trillion. So you're dealing with something that is one of the largest threats in the world. It is the size, and these are reported crimes, by the way. Unreported are many, many more. And so if you take many insurance companies around the world, like Allianz or different groups which are there, they've categorized cybersecurity as the #1 risk in the world today. So as per reports, industry reports, they vary from $200 billion, the investments and size at which the cybersecurity market is growing, to $2 trillion McKinsey and all have given. But even if you were to take very conservative estimates also, it's a very, very large market. Lots and lots of jobs and opportunities in cybersecurity. And it is growing at a tremendous pace for the simple reason that digitalization is growing at a tremendous pace. Almost anything that you see and touch has a digital component in it. And that is the reason why we as an industry body, so we are the industry body here, so we look at things through the industry lens, Okay. Of course, we work with government, academia, and all that, because industries where we believe investments are made, jobs are created, collaborations are forged, research is funded, lot of things, the practical aspects. Of course, we do have our eye on the upcoming things like quantum computing and many other areas, but the fact of the matter is that we need to solve today's problems and the ones that are coming up. So cybersecurity, back to that again. About 137 countries in the world are adopting privacy laws. I've already started adopting data protection and privacy laws. India last year. And of all the civil and criminal laws, if you were to take, the highest penalties are for breach of data, 250 crore rupees, which is the highest. Okay, so companies are investing heavily. So what is a major problem? We in the industry have a tendency to look at it as an opportunity. So here in India, we can service the global markets if we build the right talent pool and we build the right expertise and we have the right, do the right research. So India has about 350 homegrown product cybersecurity companies, product companies, okay. And of course, as an industry body, we work with many. So we work with the industry, tech industry, which is a large, medium, and small companies, including startups. We incubate about 45 cybersecurity startups. The second is government, central government, state government, law enforcement agencies, defense and policy making bodies. And the third is academia and R&D. We do research, hackathons, we do conferences, talent recruitment, help in that, okay, facilitate that, and also forge a lot of international collaborations. And fourth is user enterprises, banks, retail, pharma companies, all the user groups, energy companies, government, defense, everybody. So these are the user enterprises. We run something called use case clearinghouse workshop to extract the critical use cases out of these, and then so that the industry can build superior products and solutions. And last but not the least, we are extremely rich in collaborations. So we collaborate with Hague Security Delta, Netherlands, Hague Center for Strategic Studies, US, at least 3 universities in US, with Israel, a whole host of companies, CyberWest Australia, and the Quad, everybody. With US also, in fact, I'm going there for 3 weeks now in May. Sorry. And so the thing is that, yeah, thank you. Yesterday. Now, we take a hackathon, for example, which is coming up, India-wide hackathon. Last time we conducted it, about 7,000, 8,000 people participated. I would urge very much the students of this college to participate. It gets you the skills in application security. And we are collaborated with Cardiff University and Hague Center for Strategic Studies also in that. Okay, Cardiff University, UK. And here the Cybercrime Security Bureau is there, JP Morgan and many other companies are, CSW and all are collaborating with it. So I'd strongly urge you to do that. And there is the other thing that is coming up is in October we hold something called Indo-Dutch Cybersecurity School, in which every day evening, 2 hours, there are sessions on all the eclectic areas of cybersecurity and privacy, many things that you would not easily get hold of. So if you were to do that, you will get the knowledge. So based on such programs we can run, continue to be in touch with us. There are over 1.5 million open jobs in cybersecurity in India alone. So please be in touch with us. The day you hear, your tenure is limited, in the sense you will pass and then you will get a degree certificate. But throughout your career, you need to be in touch with industry bodies which can shape your career. You can read the industry reports, authentic reports. For example, India Cybersecurity Landscape Report, GCCs, how they function, okay, and what the cyber threat reports are, domestic. They are authentic. Rather than asking a few of your friends here and there, you get very authentic stuff. And I am very thankful to be part of this, and we wish VNRVJIET and the conference every success, and all the partners and sponsors. So we hope to do more of these, and all the best to all of you. Thank you.
Thank you, sir, for enlightening us on the relevance of cybersecurity. In India, the industry bodies generate economy, invite funds, and incubate research. We appreciate your take on collaboration and exchange of ideas.
Now, I request you to direct your attention to the stage and help me welcome Professor D. Srinivasacharya Garu.
Respected dignitaries on the dais, participants, guest speakers, faculty and students. Very good morning to you all, good afternoon to all. On behalf of the Andhra Pradesh and Telangana Society for Mathematical Sciences, on my personal behalf, I welcome you to this international conference on applied mathematics and advanced data analytics for Industry 5.0. So previous speakers have told about the importance of mathematics, mathematical modeling in data analytics, space technology and remote sensing. Just I would like to give a brief about Andhra Pradesh and Telangana Society for Mathematical Sciences. Andhra Pradesh Society for Mathematical Sciences was established in the year 1986 with the pioneering efforts of two stalwarts, Professor N.C.H. Pattabhiramacharyalu and Professor P.V. Arnachalam, with its headquarters at the Department of Mathematics, Usmania University, Hyderabad, and renamed as Andhra Pradesh and Telangana Society for Mathematical Sciences in the year 2018. It has gained the admiration of all researchers from various research academic organizations and industry. This has been accomplished because of the enormous selfless hard work and dedication from the certain number of people from its inception. The society has made significant progress in encouraging interdisciplinary research in the mathematical sciences. Young researchers or scientists are encouraged by society through specifically designated awards. Since its inception, the annual congress of the society have been held at various universities and other reputed institutions in Telangana and Andhra Pradesh. These congresses draw large number of researchers, particularly young ones, from all over the country and also from abroad, and help in promoting interdisciplinary research. APTSMS has utmost responsibility to carry out more tasks for the benefit of the researchers in mathematical sciences. Among them, starting some APTSMS chapters to conduct its activities, giving recognition to established researchers, or some that can be given due consideration in near future. The faculty, research scholars, and students of various universities, institutes, and colleges in the states of Andhra Pradesh and Telangana can register as life members, annual members, and student members of this august body. The institutions, organizations, and education institutions can also register as corporate members. One of the objectives of the society is to encourage the universities and other institutions to organize international conferences, symposia, seminars, etc., to promote the importance of important applications of mathematics in various fields of science and technology. I am extremely glad that VNRVJIET Institute of Technology and Science, Pragati Nagar, Nizampet, Hyderabad, has consented to host international conference on applied mathematics and advanced data analytics for the Industry 5.0 during 25th to 27th April in collaboration with APTSMS. I take this opportunity to convey my sincere thanks and appreciation to the management and the organizing team of VNRVJIET and also the researchers who have consented to participate in this conference. I hope that 3 days period of the conference allow all participants to interact actively and keep themselves updated on the present state of the research in applied mathematics and data analytics for Industry 5.0. Thank you very much.
Thank you so much, sir, for your insights and welcoming the participants and researchers.
Without further delay, let us all welcome Dr. Ravi Sadasivani to share their enriching thoughts.
Ladies and gentlemen, esteemed colleagues, distinguished guests, and students, it is with a great honor and humility that I stand before you today as we embark on this momentous occasion, the inauguration of the ICAMADA’2024 conference. As we gather here from across the globe, representing diverse backgrounds, expertise, and perspectives. We unite in our shared commitment to the synergy of the applied mathematics in advancing artificial intelligence, machine learning, and advanced data analytics. In our pursuit of innovation, we must recognize the pivotal role of applied mathematics in key domains such as geospatial analysis and cybersecurity. The field of spatial sciences encompasses location across every domain, has emerged as a critical interdisciplinary discipline bridging geographic data with scientific analysis. Its significance cannot be overstated, particularly in addressing multifaceted societal, environmental, and health challenges. ICAMADA stands as a collaborative beacon where pioneers and visionaries converge to explore the frontiers of intelligent computing and location-based data-driven solutions. Our collective efforts hold the power to shape the future of industries, economies, and societies worldwide. As we stand at the threshold of a new era, it is imperative that we approach our work with steadfast dedication, unwavering integrity, and a profound sense of responsibility. The advancements we make in artificial intelligence and advanced data analytics have the potential to revolutionize healthcare, finance, education, transportation, and countless other domains. But with this power comes the obligation to ensure that our innovations are ethically sound, inclusive, and aligned with the values of humanity. Embracing diversity as our strength, let us foster an atmosphere of openness where knowledge is shared freely and partnerships are forged across diverse disciplines and cultures. Together, we can address pressing global challenges from climate change to social inequality, leveraging the transformative potential of artificial intelligence and advanced data analytics for the betterment of humanity. With enthusiasm, determination, and a shared sense of purpose, let us embark on this conference. Together, we have the power to shape a brighter future for generations to come. I express my sincere gratitude for the esteemed presence of distinguished individuals from ISRO and our VNRVJIET and ICAMADA committee, faculty, students, scholars, and other attending delegates. Lastly, I would like to express my heartfelt thanks to all our sponsors. Without their generous support, this conference would not have been possible. Thank you.
Thank you, sir, for tying up the interdisciplinary subjects that have come together in this conference and its relevance for humanity's future.
Now, I request Ms. Trishita to take over.
Before we move forward, I would like to take a moment to express our sincere appreciation and gratitude to all those who have made this event possible. Organizing a conference to this scale and significance requires immense dedication, tireless effort, and unwavering commitment of numerous individuals from a wide range of organizations. Your hard work, passion, and attention to detail have not gone unnoticed, and it is time to celebrate your collective efforts. Let us now proceed with the felicitation ceremony, where we'll have the opportunity to acknowledge and celebrate the outstanding individuals who have made significant contributions to the conference. It is my pleasure to invite Lieutenant General Girish Kumar sir to please come forward. I request C.D. Naidu sir to please felicitate. Now I request Dr. Ritu Kharidal ma'am to please come forward, and J.S. Rao sir, General Secretary, VNRVJIET and Vijnana Jyoti, and Dr. K. Anuradha ma'am and Y. Padmasai ma'am to please felicitate. Now I request Professor Arun Kumar Pujari to please come forward. And I request Dr. T. Jayashree ma'am to please felicitate. Now I request Dr. K. Srinivas sir to please come forward. And I request Dr. Ravi Sadashivani sir to please felicitate. I request Dr. B. Sriram sir to please come forward, and Dr. B. Chanakeshwar Rao sir to please felicitate. I request Professor T. Srinivasacharya sir to please come forward, and Dr. M. Rajshekhar sir to please felicitate. I request Professor Aaron Didlake sir to please come forward. And I request Ramesh Chandra sir to please felicitate. I request Professor George M. Banzaf sir to please come on to the stage, and Dr. D. Srinivas sir to please felicitate. I request Dr. Malladi Satyanarayana sir to please come forward, and Dr. B. Chanakeshwar Rao sir to please felicitate. Now I request Professor Sat Narayan Gupta to please come forward, and C.D. Naidu sir to please felicitate. Thank you, sir. Now I hand over the stage to Ms. Madhura and Sansita.
Thank you once again for your dedication and commitment. With the inauguration of ICAMADA 2024, we now set sail on a voyage of knowledge sharing and exploration. Let us embrace this opportunity to exchange ideas, build network, forge new partnerships, and pave the way for a brighter future in Industry 5.0. On behalf of the organizing committee, We extend our heartfelt thanks to all our distinguished guests, speakers, and delegates for gracing us with their presence today. We look forward to the fruitful discussions and the insights that lie ahead.
As we gather here today to inaugurate this conference, it is my privilege to extend our heartfelt gratitude to our generous sponsors. Their assistance and commitment have made this event come true, and we are truly grateful for their partnership. On behalf of the organizing committee, administration, and all the attendees, I extend our sincerest thanks to each and every one of our sponsors. Your generosity, magnanimity, and vision are truly appreciated. We look forward to continuing this fruitful relationship.
Thank you. And now I request all the dignitaries to join us for a group photography. Thank you all once again. Thank you all the dignitaries. We request you all to take the seats of the dais. Thank you all the dignitaries. We request you all to take the seats of the dais. I request you all to join back after half an hour.
Just wait for a moment. Good afternoon, dear participants. We request you all to join back after 30 minutes. Now please proceed for lunch. Lunch is arranged in VJIM canteen. Our organizers will guide you further. Thank you. Organizers, volunteers, please guide the audience. Thank you.